Alright, so today we're going to talk about intervals of increase and decrease, and what that means is we're just going to define where a function is increasing and where it's decreasing, which we did yesterday, right? We actually did do that. So let's go ahead and start off with a polynomial, because polynomials are easier. Go ahead and copy down this one. Alright, so we're basically just going to be following the same exact steps, right, that we did last time. So step 1, find your derivative. Step 2, find where it is undefined and where it equals 0, so we can find our critical value, right? It's a polynomial, so there are no places where it's undefined, but we can find some places where it equals 0. So we would start with what here? Factoring, right? So I would start by taking out a greatest common factor. 3 does, but we can go bigger. 6. Take out a 6x there. And that would leave me with 2x squared minus x minus 15. And then we would factor this using reverse Euler or box method. Let's see if that works. 2x plus 5 and x minus 3. So that would be negative 6 and positive 5, which would give me, yeah, you're good. Which means now I've got 3 critical values. This one would give me 0. This one would give me negative 5 halves. And this one would give me 3, right? See a lot of pencils moving. Huh? 2.5?
Yeah.
Yeah. That would be fine. If you prefer decimals, which probably is easier with number line things anyways, using decimals. So, any questions so far? None of things different, right? Everything's exactly the same. So we're going to go ahead and set up our number line. I have a negative 5 halves. I've got a 0. I've got a 3. And we don't want to forget on our ends we have infinities. So we are going to have 4 intervals, it looks like. And we're going to do f prime. We're going to figure out what those are. So what's a good number for negative 5 halves to negative infinity? Negative 4 works for me. How about in here? Sure. How about in here? And how about in here? Okay. So at this point, I'll let you guys use your calculators if you want to, or if you just want to do it mentally. Sometimes it's easy to do it mentally just by looking at the factored one. So for instance, if I wanted to plug in a negative 4, I know that this piece would come out negative, this piece would come out negative, and this piece would come out negative, and 3 negatives make a negative. So you could do it mentally like that, or you can practice your calculator stuff that we learned yesterday. But either way, I'll let you guys do the other 3. So go ahead and take a moment and figure out. Oh, wrong block. He got moved. I forgot. Sorry. Nick, I'm in this wrong block. So embarrassing. I have the right cards here. All right. Let's try this again. Jillian. She's in this block. What'd you get here? Okay. I agree. Heather, what'd you get here? Negative. And Eric here? Yeah. In case you didn't notice, it almost always just goes back and forth, right? Almost always. It's possible that a function could have a positive slope be 0 and then go positive again, right? So you got to be careful. But most of the time, it will just go back and forth like that. Because anytime you get a 0 slope, usually it's because it's going back downwards, right? So, all right. So now this is where the question is different. I'm not going to decide what the mins and maxes are. I'm going to say where the intervals of increase and decrease are. So, anytime the slope is negative, that's where the function is actually decreasing. The slope is negative, right? So, and where it's positive, it's increasing. So this interval right here is an increasing interval. So it's going to be negative 5 over 2 to 0 is an interval of increase. And so is this one over here. So I'm going to put a U for, just means like it's unified with. Also this interval from 3 to infinity. And you'll notice I'm using parentheses instead of brackets. Now the reason for that is because, well, with the infinity, you can't equal infinity. But for the numbers are critical values, which means that the slope is not positive here. The slope is 0 there, right? So that's not a positive slope, which means it's not increasing at 0. So if you're telling me where f of x is increasing, it's not increasing at 0. So we want to put a parenthesis to make sure that that's not included in the interval of increase. I was told that AP people aren't going to be that sticklerish about that kind of stuff. But just so you know, that's technically the right way to write it. And decreasing is going to be from negative infinity to negative 5/2, unified with 0 to 3. That's our answer for today. So you see it's actually less work because instead of finding mins and maxes and then plugging it back in to actually figure out what those are, all we're doing is saying, okay, which ones are positive and negative. Was it? I don't know. Oops. All right. So, let's go ahead and proceed a little bit. Now, I don't think you guys need this to do one like this, but if you feel like you want to, we can. I could give you a polynomial. So we could just do a basic one just so you guys can practice that. Or we can move into some harder ones. So what would you guys like to do? How many of you guys want to do like an easy one real quick just to make sure we have the idea? How many of you guys want to do, so you want to do harder ones then? Okay. So we'll do some harder ones. So I really don't like the first. Huh? Yeah, it's not going to happen. But so by that it really won't, because this guy here, the next one is. Oh, jeez. No. That's easy. That one's easy. This guy is a pain in the butt. Actually, the piecewise function is pretty easy. This one's not. Oh, that function was. All right. So go ahead and write that one down. It's not so much that it's a trig problem. The issue. It's the fact that the inside is not just x, and that creates a little bit of an issue. Yeah. Huh? Yep. Not right now. So here we go. Let's find the derivative. Now I'm gonna let you guys do it. I'm gonna give you about a minute, and I'll tell you this much: it's a chain rule. So I'll pause, and I'm gonna give you. So this is the derivative of the outside. The derivative of sine is cosine, and the derivative of the inside. That's like 1/3 x, right? So that's just 1/3. So derivative of the outside times the derivative of the inside, you get that. So that's not too bad. Let's go ahead and ask ourselves, where is it undefined? Nowhere's the right answer. Cosine is defined everywhere, but since there's an inside function, you do need to look on the inside too. Is this undefined anywhere? No. So we're still good. But do understand, like if I had 1/x on the inside, then we would have a place where it's undefined, right? So you still got to look at the outside and the inside simultaneously. So it's never undefined, so we're not going to get any critical values that way. But we do want to find out where it equals 0 And this is where things get a little bit more interesting. Okay. So, anytime you have, you guys know this is what cosine looks like, right? But when you multiply your x or you divide by x, you guys remember what that does to the shape of your graph? Yeah, nice job, Joe. And as for you guys who had me last year, I'm hurt. Okay, you're making Macmillan?
Yeah.
Macmillan looked better than me. I appreciate it. She went like this. It's a compression or a stretch.
Yeah, I didn't remember that.
That's okay. You had the idea. And so, you know, usually with cosine, right, it goes from 0 to 2 pi before it completes its cycle. But whenever you, and that's the interval we're looking at, but whenever you divide it by something, that changes it. It either compresses it or stretches it. Now, you don't need to know which it is, but it stretches it in this case. So what's going to happen is this thing's going to end up looking something like this now. It gets a lot more stretched. So what that means is that's going to make things a little more interesting when you're trying to solve for x. So I'm going to show you guys how we can handle this. Now, I'm not sure how your previous teachers did it, but I'm going to teach the way I did it. So anytime you have extra stuff in here, other than just an x, we're gonna replace it with a u, kind of like u substitution, right? So we have 0 equals 1/3 cosine of u. And now we're just going to solve this the way we normally would. Okay? So multiply both sides by 3. And then bonus points. Hands in the air. Tell me what the answers are. Anybody? Pi over 2 is 1. Good, Cal. Anyone else? Is there another one? Is that you? Who? Oh, Jackie. All right. All right. That's right. So there's 2 places then that give me that value. All right. Now, because we have a stretch or compression, right? You can actually end up with more than those answers. You can end up with more or even less. It depends, right? So here's the thing. You guys agree that pi over 2 is a solution, right? Don't you agree that if I add 2 pi to that, that's also a solution, though? Because that's another whole circle around, put you right back where you were, right? And couldn't you do that again? And again and again and again. So you can add 2 pi however many times you want to. Okay, in case you guys don't remember, this is called the general solution from last year. Same thing over here. So we have to do this because it's not just a normal cosine function. It got compressed. So now we have to include these extra cycles in because it's getting compressed. So we may end up with more cycles or less cycles within our original 0 to 2 pi range. All right. Now, what did I say that u was? X over 3. So now we're going to replace u with this again. And now we can solve for x. So what would I do if I wanted to solve for x here, you guys? And how would I do that? Multiply everything by 3. So I end up with 3 pi over 2 plus 6 pi n, right? And I also end up with 9 pi over 2 plus 6 pi n. So what was my period originally? For cosine, it's usually what? A full circle, right? But now my period is So in other words, to complete a full cycle, you have to go further, and that's why it's a horizontal stretch. All right, but anyway, I'm adding just old pre-calculus knowledge here. All right, so now I need to find all the possible solutions that are actually on this interval. What this is a general solution. It helps you generate as many solutions as you need. So here's how you do that. You pick numbers for n, and you get your x's. So for instance, if I plug in 0 for n, what would I get as an answer for x? I would just get 3 pi over 2. Is that on my interval? Yes, it is. What if I plug in 1? I would have 3 pi over 2 plus 6 pi. Is that on the interval from 0 to 2 pi? It's not. This is already bigger than 2 pi, right? So if you add anything to it, it's out. So we're just going to say, okay, I don't care about that answer. That's still a solution, but it's not a solution on the interval that I care about. So that's too big. This is just right. Let's try to go backward. Let's plug in -1 for n. If you plug in -1 for n, 3 pi over 2 minus 6 pi. What will that come out to be? Will it be on this interval? No, because this is way bigger than this, right? So you're going to end up with a negative, and negatives are obviously not on this interval. So we only have one solution there. We have one critical value. It's a 3 pi over 2. All right, now over here, we would do the same thing. If I plug in 0, what do I get? Is that on my interval? Well, 9 pi over 2, if you want to divide it, is 4.5 pi. So is that on my interval? No, it's too big. So do you think if I add anything to it, by making this 1 and getting 9 pi plus 6 pi, do you think that's going to be on my interval? No. How about if I do a -1? This is 4.5 pi. If I take away 6, it's not right. It's going to be negative. It's 4.5 because 9 divided by 2 is 4.5. Yeah. So this one does not give me any solutions on my interval. So you guys are, my last block expressed their disdain at all this work, so we can know that, right? But if you didn't know this, you might have included this as one of your critical values and ended up with a false answer, right? So you don't want to do that. It was just this one that worked. So all that being said, I've never seen a question like that on the AP exam. But it is in your homework. And so I thought I would go ahead and talk to you about it. And hey, we can rise above the level of expectation. You gotta wanna.
But I know.
Yeah, I feel like
But we're not even done though. We still have stuff to do.
You're right.
What?
Set up your number line and find your intervals of increase and decrease. This is the easy part. This is the easy part.
dead serious.
All right. Oh, by the way, what goes over here?
0.
And it doesn't go to infinity, right? Because it repeats, and they gave us an interval to stick on, so they're a little bit different. So we have 2 intervals. You guys can use your calculators. There's a few ways you could do this. If you know your unit circle, you can pick unit circle values and do it mentally. But honestly, I would just change this into a decimal. Like this is 3 times 3, which is 9 divided by 2. So it's going to be about 4.5-ish. So pick a number less than 4 and a number greater than 4, and you're probably good.
Yo.
And just use your calculator. And how about over here, Josh? Good choices. Okay. So I'm going to ask someone else. Jacob, what'd you get for your slope here? And there you go. So our interval of increase is 0 to 3 pi over 2. and our interval of decrease is 3 pi over 2. So I'm glad I only have to go through that problem twice today. I don't like it either. I think that's very tedious, but I wanted to take the opportunity to review that stuff with you guys. It's not like you're going to see it very often, the general solution thing. I mean, you're obviously going to see the trig stuff a whole lot, but not necessarily the general solution. All right, the next one I promised, a little bit nicer. Go ahead and copy down this one. Good. Now, did you remember the little detail? Yes, nice job. Now, sometimes you'll keep it, and sometimes you won't. How do you know when you're not going to keep it? That's true. How do you know? Yeah, Jocelyn said, it's when you plug it in. So if the slope from the left is equal to the slope from the right, then it's smooth and the derivative exists there. If the slope from the left is not the same as the slope from the right, then it's a cusp, and it doesn't exist. So the slope from the left of -1 is, what's the slope from the right of -1? -2. So it's a sudden change, that's a cusp. So it's not differentiable, therefore the slope cannot equal -1. You plug in them. We don't plug anything in here because there's no x, but you do here. All right, so there's that. So there's our derivative. So now I'm going to let you guys wrestle through the next question. I want you guys to find where it equals 0 and where it's undefined. Go ahead. I'll give you a moment. See if you can find them. Where is it undefined at? No, it is undefined somewhere. Yes. Remember I said that's where the cusp was? You can't have a derivative at the cusp. So a lot of times you won't have, whenever you do piecewise, that'll be one of your critical values. Jesus, where did you find that it was equal to 0? Okay. Let me try. Michael, where did you find that it was equal to 0? There you go. Sure. Yeah, good. So here's the thing. First of all, where does it equal 0? Well, this can never equal 0, right? But this could equal 0 possibly. And I'll say possibly for now, and I'll tell you why. So if we divide by 2 on both sides, we get 0, right? But the question is, am I allowed to do that? What was my x value? 0? Is that on this interval?
No. Yes.
It is. So can the slope equal 0? Yes, it can. Now, if you got 0 here and it was on the wrong interval, then you're not actually even allowed to use that piece to get it. Does that make sense? All right, so now you got your critical values. Go ahead and finish it. The rest is easy.
I finished it. It doesn't make sense.
Oh, yeah? We have -1 and 0, -infinity, positive infinity. I've got 3 intervals that I need to test. I don't care about what number you chose because it doesn't matter, just so long as you pick something in the interval. So Jocelyn, what number did you choose here? -2. And what did you get for your answer there? Yes, good. So do you guys see that if I have a -2, it's going to be 2? Now, let's see why. If I choose -2, which piece do I use? Use the top. So the slope would be 2, which is a +2, right? Now, how about this one, Jocelyn? What did you use? -0.5. And what did you get when you... Now, for that piece, which piece did you use? It is the bottom one. So if you had that, what would you get? Negative, right? And then finally, what did you plug in here? 1. And if you plug, that's going to be the bottom again, right? So, all right. So you guys have your intervals of increase and decrease, right? What time do we get out of here? 1:02. Oh, I don't think that's time to do enough. So there is another one, but I'll do it after you guys leave today, and I'll upload it, and I'll also do some homework help videos both for yesterday and for today. And you guys can look at those if you need them. This one here is a product rule.
Yes.
Okay, so I'll show you how to do a product rule. So when you see this one on your homework tonight, you will see one like that. You can watch the rest of this video if you like, okay? Last example. So for this one, we have to do the product rule. In case you guys forgot the product rule, anytime you have two functions that are being multiplied and you want to find the derivative of that. Hey, how's it going, man? You're good. The way that we did that was you're going to have something times something equals something times something, and that is the GF, where on this one of them is primed, and the other set, the opposite one's primed. That's the product rule. Okay, so for this particular problem here, if I were to call this the x my g function, and if I were to call this my f function, then f prime, erase that, would be g times f prime plus g prime times f. All right, so in this case, I'm going to start with the easier one. Let's start on this side actually. So the f is going to stay the same here, so it's just going to be square root of 1 minus x squared. And the g prime, the derivative of x, is just 1. Now for the messier part, we have over here g, that stays the same. This is the messy part. I got to find f prime. So I'm going to show my work off to the side here. So if I'm calling this particular function f, and I need to find its derivative, this is actually going to be a chain rule. First of all, I'm going to rewrite it as a half power, and then I'm going to apply the chain rule. The outside function is the half power, the inside function is the 1 minus x squared. So if I take when you do a chain rule, you do derivative outside times the derivative of the inside. So the derivative of the outside would be multiplying the half to the front, don't change the inside, and subtracting 1 from the original power. The derivative of the inside would be negative 2x. Now that needs to be cleaned up a little bit, okay? First of all, this 1 minus x squared to the negative half, that's going to go down to the denominator, and it's going to be a square root. So, and this negative 2x is going to go to the numerator because it's just it already is in the numerator, right? So if I put all those together in that way, I end up with the negative 2x on top. I've got a 2 on the bottom from right here in the front, and then the 1 minus x to the negative half now looks like that. And we can reduce this more, and we end up with this expression. So that's f prime. And that's what needs to go over here. So we have x over the square root of 1 minus x squared, and it was a negative, so I'll put a negative there. All right, so that's ugly stuff number 1 that we have to deal with there. Got to remember your product rule, got to remember how to take the derivative of square root, got to remember your chain rule, a whole lot of calculus, not to mention now we get to do a whole lot of algebra. Because we need to simplify this before we go any further. All right, so f prime of x is going to be x times x is going to be negative x squared. 1 times anything just stays the same. Now, to simplify this further, we need to make this one fraction, and to do that, we need a common denominator. So I'm going to multiply this side by this denominator in the bottom. So I have a common denominator, but whatever you do to the bottom, you have to do the top. So now I have to multiply the top by that as well. And that's rather convenient because notice that we're multiplying that square root by itself. And if you remember your algebra, what that means is that the square roots are just going to cancel out, and I'm left with just the 1 minus x squared, no more square root. Okay, so now that we have two fractions with a common denominator, we can just add the like terms. I've got a negative x squared here and a negative x squared here. Those can be combined into negative 2x squared. So I gotta make me some space here. So we now have this. And that is as simple as that's going to get. Okay, now that wasn't simple, but that's as simple as we're going to get it. Now we're ready to actually move away from algebra and back into the calculus here. Remember, we're trying to find intervals of increase and decrease. So to do that, I need to find my critical values. Critical values are where the expression is equal to 0 and where it is undefined. So it equals 0 when the numerator equals 0. I did a problem like that last time. And it's undefined when the denominator equals 0, which we did last time as well. So let's go ahead and get down to business here. I'm going to minus 1 on both sides. Divide by 2. Square root. And I'm just going to go ahead and do decimals here. I mean, we could have written this as a 1/2. And I'm just going to stick with decimals, if you don't mind. Let me take the square root of 0.5 here real quick. 0.707. So basically I'm getting plus and minus 0.707 for two critical values. This one over here, to solve where it's undefined, I would start by squaring both sides, which would give me this. I would add the x squared to both sides, which would give me this. And then I would square root both sides, which would give me this. So I've got two more critical values there. All right, so I've got all my critical values, and now we are ready to go ahead and find out where our intervals of increase and decrease are. All right, so number line, I have -1. I have negative 0.707. I've got positive 0.707. I've got 1. I've got infinity, negative infinity. And that gives me a total of 5 intervals that I need to test. Okay? So remember, at this point what we want to do is we want to plug in numbers from these intervals into our derivatives. So for my first interval here, from -1 to infinity, I'll plug in -2. For the interval from -1 to -0.707, I'll plug in -0.8. For -0.707 to positive 0.707, I'll put 0, and so on. Okay? A lot of things to plug in, and not a very friendly thing to plug in too, which means that probably want to use our calculator on this just to save ourselves some time. Let me see if I can bring up my calculator here. Oops. There it is. Back up a little bit here. Okay. So the first thing I'm going to do is I'm going to type in this. Well, you know, I'm going to, like I told you, we always want to start by storing an x value actually. So let's do that. So the first x value I want to plug in is a -2. So I'm going to store -2 under my x value. All right. And then I'm going to type in my function, which is over here. Now, when you type this in, you got to make sure your entire numerator is in a set of parentheses, and it can't hurt to also do it with your denominator. Okay? In some cases, it's just going to be necessary to do that, so good habit to make. So we have negative 2x squared plus 1 divided by the square root of 1 minus x squared. Close the parentheses, and we should be able to push enter, and it says error. Now the reason for that is because if you were to graph this function, you're going to find that it doesn't exist to the left of -1. So anything over here, it doesn't matter what you plug in, you're always going to get an undefined answer. The function does not exist to the left of -1. Okay, it's a little bit more obvious if you were to graph it, but I'm not going to at this time because it takes more time. I'll just get the problem done here, but you are welcome to graph it if you want to see what I mean. Now let's go ahead and go back and we will plug in the next values. All right, so now I want to do -0.8. Store that. Bring back our function. And I get a negative slope. Next one I want to plug in is 0. 0 is pretty easy just to do mentally, I think. If you plug in 0 here for the x, you're just going to be left with 1 on the top. If you plug in 0 here on the bottom, you're going to be left with 1 on the bottom. So you have 1 over 1, which is 1, and that's a positive value, so that slope's positive there. And, you know, if we keep the pattern up, I can predict this is probably going to be negative, but there are those rare occasions where it's not what you'd think. So let's go ahead and do it anyway. Let's go ahead and store the next value. X is 8.8, I mean. And we will bring up our function and evaluate it. It's also negative. Surprise, surprise. And what do you think is going to happen over here? You have two good guesses. One is it's going to be positive. The other good guess would be undefined. It will come out to be undefined. I'll promise you that. But just to, if you want to verify it, you can. But the function does not exist to the right of 1 either. So we have our intervals of increase. We have our intervals of decrease. So let's write them out. I'll put I for increase, D for decrease. That's not great math writing, but in the interest of time, and I'm going to do your guys' homework help video today too, so I'm going to be buzzing through things a little bit quicker. Now, if you were to look up your answers in the back of the book, they're not going to have the decimals there. They're going to have it as radicals and fractions and stuff. It doesn't matter to me which you do. And some of you guys probably noticed that this is actually the decreasing one, so I need to reverse this. So, anyway, there you go. You will see one homework problem like that today. I'll probably still include it in the homework help video if you need to see it and you can't get it on your own. But like I said, you definitely want to try these things on your own. All right, so now I'm going to make some homework help videos for you guys for last night's homework, which was 5.4, and tonight's 5.5.